Welcome back to the Edgeverse. This is the podcast where we explore the latest innovations shaping the secure, connected edge. And I'm Kyle Dando.
And I'm Bridgette Stone.
Well, normally, I'm the one traveling to events and making Bridgette jealous with pictures of all the things I see on the road. But this time, the tables have turned. Bridgette just attended NXP Tech Days in Silicon Valley, while I stayed home in the Texas heat. I just had to follow along with all the excitement that I saw her having online. And you know what? As she usually says, it gave me a serious case of FOMO.
And I have to admit, it was a pretty incredible event.
Well, you were nice enough to help me out a little bit. So today we're going to do something a little bit different. Rather than interviewing a guest, I'm going to take the opportunity to learn about everything behind the scenes at the NXP Tech Days. How I'm going to do that is I'm going to talk to Bridgette about what she thought were the biggest announcements, some of her favorite moments, and maybe one theme that really connected with everything that she saw.
Because while there was an exciting product announcement, dozens of demos and technical sessions, what really stood out was how everything fit together around one vision for the future of edge computing.
Okay, Bridgette, let's start with that first impression that you had. When you walked into the event, what was the first thing that stood out to you?
Honestly, the energy. From the moment registration opened, the event was buzzing. Engineers were gathered around demos, customers were asking incredibly detailed technical questions, partners were showcasing new solutions, and conversations continued everywhere, in the hallways, during breaks, and inside the tech lab. That's what makes Technology Days so super special. It's not just a series of presentations. It's a place where developers can interact directly with the engineers who design the hardware and software they're evaluating. This year's Silicon Valley event welcomed more than 600 attendees, featured over 50 NXP and partner demonstrations, and offered a full day of technical content covering AI, industrial networking, automotive, embedded software, security, robotics, and much, much more.
Bridgette, that's one of my favorite things about the Tech Days. It's, as an engineer, you sit in your cube and you may be listening to this TechCast in that situation where you only have access to like documentation or maybe a really great webinar, but standing next to the actual working demo and asking a subject matter expert, how could this work in my own product? That is a completely different experience.
Exactly. And those conversations are often where the best ideas happen.
All right. So Bridgette, from everything I heard, Charles Dachs' keynote really set the tone. What was the biggest takeaway from his keynote?
It really did. Charles challenged everyone to think differently about AI. Instead of talking about AI as something happening in a data center or the cloud, he focused on physical AI, AI that's embedded into robots, industrial equipment, autonomous systems, and intelligent machines interacting with the real world. One analogy really stuck with me. He compared physical AI to the human nervous system, where your brain handles reasoning, your cerebellum coordinates movement, but your spinal cord reacts instantly. You know, if you touch a hot stove, your hand pulls away before your brain consciously processes what happened. And that's because some decisions simply cannot wait. Charles explained that intelligent machines need the same kind of architecture. Some decisions require high-level reasoning, but many need to happen instantly, close to the sensors and actuators with extremely low latency. We call this the neural axis architecture, where intelligence is distributed across reasoning, coordination, and reflexive layers instead of relying on one centralized processor.
Yeah, and I love that analogy that he made because I think every engineer can understand what latency means when you're talking about that hot stove.
And once you've heard that keynote, you started seeing it reflected everywhere throughout the event.
You spent quite a lot of time at the event. You were talking with analysts and media before the event. What kinds of conversations were you having with them?
They were fascinating because they focused less on individual products and more on where the industry's heading. We talked about NXP's industrial edge strategy, why AI needs to be right-sized for applications instead of simply chasing a peak tops number, the growing role of robotics, and how secure connectivity becomes even more important as intelligence moves into physical machines. We also introduced the new MCX A5 family, which generated a lot of discussion because it fits directly into that broader vision.
That's cool. I mean, it's great to have a new product launch like the MCX A5, but to be able to talk about the broader applications and talk with the media and the press about those things, that's what really makes this event exciting. Let's go back to that announcement. I kind of didn't give it the credit that was due. The MCX A5 had a lot of buzz after the show. Could you talk about what the MCX A5 was introducing and why it was so successful?
Absolutely. MCX A5 was definitely one of the busiest stops in the tech lab. One thing Charles said during the main speech really stuck with me, and that's the industrial edge AI can't reach its full potential without trusted real-time data. There are millions of sensors, actuators, controllers, and end edge nodes deployed today that either aren't connected or still rely on legacy communication. And if you can't easily collect and trust that operational data, it's much harder to build predictive maintenance systems, intelligent automation, or AI at the edge.
Okay, I agree. You have all those sensors and you're trying to get connected with them, but what does the MCX A5 do that helps with that?
So the demo itself was wonderfully simple. A sign read one wire, four boards, no switch, no master. So people would stop, read it, and immediately ask, wait, how does this work? So the answer was four MCX A577 boards communicating over a single twisted pair Ethernet connection using an integrated 10-based T1S. No external Ethernet switch, no central controller. The boards were exchanging live temperature readings in LED control commands using the 10-based T1S PHY and PLCA for deterministic collision-free access. You could literally watch people having that aha light bulb moment. They weren't thinking about Ethernet anymore. They were thinking about simpler machine designs, fewer components, lower system costs, and connecting more edge devices throughout a factory.
Yeah, a light bulb moment goes on when you learn that one wire Ethernet simplifies the designs that people have been tackling over the last decade.
And another feature that generated a lot of discussion was the topology discovery. As industrial networks become larger and more distributed, simply knowing what's connected and where becomes incredibly valuable. It's another example of solving a real engineering challenge instead of simply adding another specification.
Yeah, and it was great to show all the customers that were walking by that this is exactly how it works. You showed how all those boards were connected with very simple interfaces. You weren't just telling them to go read the data sheet and read about the features. You actually showed them, and you showed them why it mattered and how it improved their designs.
Exactly. And to me, MCX A5 isn't just another MCU. It's one of the building blocks that helps bring more trusted, connected intelligence to the industrial edge.
Okay, so once the attendees listened to Charles' keynote and they broke down everything that he said, how could they start to see that physical AI story throughout the rest of the event? Maybe the showcase or some of the labs and the classes?
So it completely changed how I looked at the technology lab. Instead of thinking, oh, here's an AI demo or here's an industrial networking demo, you realize they were all solving different parts of the same problem. How do intelligent machines perceive their environment? How do they make decisions? How do they communicate securely? And how do they react in real time? You could walk from robotics to vision AI to industrial networking, software and tools, autonomous systems, and suddenly it all made sense. These weren't isolated technologies, they were pieces of one complete edge ecosystem. Charles kept going back to three words during his keynote: power, latency, and trust. Those are the non negotiables for physical AI. Think about a robot, a drone, or industrial automation. You can't compromise on latency because decisions have to happen immediately. You can't ignore power because many of these systems operate within strict energy budgets. And you absolutely cannot compromise on trust because these devices are making decisions that affect safety, productivity, and critical infrastructure. One slide in the keynote said something that really stuck with me. Because at the edge, reality hits hard. And so in physical AI, trust is not judged when everything works, it's decided in the worst possible moment, or what we like to call Murphy's Law.
I know that pretty
So
well.
we all do. Examples like a safe robot needs to fail gracefully, a drone that can still hover and land, a vehicle that pulls over instead of freezing. a humanoid that doesn't just keel over, but stabilizes plans and protects its surroundings. And that perfectly captures why edge computing is different. These systems don't get a second chance. They have to make the right decision at the right time.
I think there's a couple great recent examples of this Murphy's Law. I think there's that one public announcement where that CEO stood in front of the humanoid and it just keeled over. That was pretty hilarious, right? Probably had some latency issues. And then
Yes.
This is a more tragic incident where the Waymo cars in Austin, the automated vehicle was stuck in the middle of the road and it didn't know how to get out of the road for emergency vehicles. When we're designing these things and you've listed those three critical areas of power, latency, and trust, we see it in the news. It's showing up every day. All right, well, that's great coverage of the event, but why don't you cover the one thing, Bridgette, that you went home and told your husband about? You spent a whole day there. He probably was wondering what you were doing away from home. What was your biggest takeaway from the event?
Honestly, it reminded me why I enjoy working in this industry so much. We spend a lot of time creating presentations and podcasts and videos and collateral, but there's something really special about watching an engineer see a live demo, ask a question, and suddenly realize how they could apply that technology to their own product and be face to face with our NXP experts in the room. It's about bringing together customers, partners, and NXP engineers to solve real problems together, whether you're interested in AI, industrial networking, embedded software, or the latest edge computing technology. There's tremendous value in being able to ask questions, compare ideas, and see everything working firsthand.
Well, Bridgette, I have to admit, you did a great job sharing all this information with me and the listeners, but I think my FOMO has increased. I absolutely must get to the next Tech Day. Why don't we put the Tech Day events in the episode notes? Any listeners that want to experience firsthand what Bridgette has shared, we'll put that in the episode notes.
Yep, we'll add that. Or you can go to nxp.com/techdays.
I would vouch that this is a great opportunity for you if you're listening. Take the time, look at the schedule, and spend a half day or a day at the Tech Day. It's a great place for you to meet with experts, explore these live demonstrations, connect with an entire engineering community, and discuss ideas and ways that these technologies can maybe apply for your own products.
And if you'd like to learn more about the new MCX A5 family, you can visit nxp.com/MCX A5, or any of the technologies we discussed. We'll include the links in the show notes. We'll also have several upcoming Edgeverse episodes where we can take a deeper dive into the MCX A5. We also had a recent MCX C launch, in addition to industrial networking, robotics, and of course, physical AI at the edge.
And as always, thanks for listening. Make sure to subscribe and tell your friends. Bridgette and I would really appreciate if you can like and make this the most popular podcast that you listen to every day.
And we'll see you next time
On the Edgeverse TechCast.